Welcome everybody to an EMnify webinar. Today's webinar is the last of the series around the EMnify Data Streamer, and I will show you how to display the location of an EMnify SIM card on an interactive map. My name is Jean Ambroise. I've been Customer Success Manager at EMnify for more than a year now, and I'm very happy to be joined by Brian Smith, who is a technical writer at EMnify. Thanks for joining, Brian.
Thanks a lot. Thanks for having me.
So first of all, I will remind all of you what the data streamer is. It's the fourth webinar around this topic, but maybe not all of you have joined before. Then we will see which information needs to be streamed from the EMnify user interface to your server in order to display the location of the SIMs. And then Brian will actually show you the step-by-step guide on how to integrate this all and have a nice result. If you have questions during the webinar, feel free to ask them using the question panel, as most of you have already seen. Thank you for letting me know it's working. And if you have questions during, so just ask, and if it fits, we'll answer them directly. Otherwise, we'll have at the end a Q&A session so that we can answer everything you may wonder. So what have we seen in the previous webinars? Very quickly, as you all know, once you use an EMnify SIM card on an IoT device, well, basically your device goes online and creates a lot of connectivity data and usage data. So we have lots of events and statistics in the EMnify user interface, which is very useful. And we enable you to use this specific data and analyze them in third-party tools using the EMnify Data Streamer. So we have already integrated specific tools such as AWS S3 and Kinesis, but we also enable you to integrate the RESTful API of your own tools, and this is what we will do today. The end result will basically look like this. We will have the event data streamer, and we will have integrated the RESTful API in order to display the location of our SIMs on Google Map. So in order to do so, specific information from EMnify events is required. And this is basically what we already display on the EUI. So we need the LAC, local area code. We need the cell ID, the mobile country code, and the mobile network code. So each mobile provider has registered themselves and received such a code. And using those four information, we can get the longitude and latitude from an API map. And today we will use the API of Google Maps. We will use different stack. So first of all, we use the EMnify connectivity, of course. And one important information is that it only works with 2G, because only on 2G do we get this specific information from the network. Then we will integrate the EMnify Data Streamer. We will use a Heroku free server, and we'll finally integrate the Google Maps API to display everything on it. The end result will be like that. We have our URL, which I'm using in Firefox, and I have the location of my different endpoints with the heat map and or the lines. I will now hand over the presentation to Brian, who will take care of the more technical part of it. So Brian, hold on, I'm putting you as a presenter. Yes.
Okay. So thanks, Jean-Ud. Thanks for the introduction. So I also have a couple of slides just to illustrate what we'll be looking at from the technical side. So we're using the data streamer as a REST API integration. First, what we'll do just to show how that works is we'll use a tool called ngrok, which I really like using this for debugging. This allows you to create a public URL, which essentially is a secure tunnel to local hosts. This is a really nice tool that I use quite often for debugging. And we'll use a very basic example of Express, which is a Node.js server. Then for the example application that Jean-Hugues showed running already, it's the exact same setup. It uses Node.js and Express as a server, but it's just we spent a bit more time adding in a few more features and doing some geo lookup with events that we're interested in. And then eventually we can deploy it onto Heroku. Heroku is also another service that I really like using for getting demo or proof of concept applications up, because you can get, I think it's 5 projects that you can deploy for free on their free tier, with a lot of very nice add-ins like this Postgres database. Okay, so when we're using the REST API integration of the data stream, this is different to the S3 integration, because here what we receive is JSON, and we receive these into our REST API application server in the form of HTTP post requests. So in the EMnify user interface, what we do there is provide a URL. And what we can do to show this off is actually to use this ngrok tool to point to localhost, and we can show a very basic example working in this case. So first, before we show that, I'll just show you the ngrok tool where you can actually download it. So if you go to ngrok.com, you just register with an account, and you can download a binary, and that sits on your machine. So what we have here is, on the left, we have a very basic Node.js application. So what we're doing is listening for post requests to my server at the root entry, and we're listening for get requests, and we're sending a 200 status back. And we can start this here with node index.js. I think this is also the very first example application that you get on Express on their documentation online. So when we run this, we start a server at localhost on port 5000, and we can open this up here. And we can see, oops, we get the response that it looks good, and we get a 200 code. So this is where the ngrok tool comes in quite handy, because now on this terminal on the right here, we can start a service with HTTP on port 5000. And what that will do is that will give us this public URL. So this basically creates a secure tunnel at this URL, which is generated every single time you start up this tool, but that points to the local host. So we can copy this and paste this into our browser, and we get the same page. So we can see this terminal on the bottom shows our Node application getting a GET request. We're sending the looks good response back. And so we can use this ngrok URL actually in the EMnify user interface. So this is something that I use quite often for debugging data streams. And where you do this, I'll get rid of this terminal on the right. What you do is you go to the technical settings page, you go to add data stream. We pick let's pick usage data and events. You pick the API type REST API, and here is where you get to pick the API callback. So I've already tested this before with ngrok URL, but of course we generated a new one this time. So we can paste in our new URL that we just generated. and we can select this from the list. So if we add a data stream now, we can see down here at the bottom, we have a new REST API data stream, and it's sending usage data and events towards this public URL. And that should be visible here. Okay, so now in order to actually see events coming in on this data stream, we have to generate some events. So what we can do is we can reset connectivity on an endpoint. Let's see if we have one on the line at the moment. Let's try this one. We already have some events coming in. So if we have a look on the right, this event just came through just now. So we have some usage data on this Jean-Ud's OnePlus phone. So this very basic node example just shows the raw JSON events coming in. And so generally I use this method for debugging, and I'll quickly set up a very basic node application that's, I mean, you can get this running with about 10 lines of code, get a public URL and paste this into the data streamer setup here, and you can have events coming into your application very quickly. So this is a nice way to test and see if your setup is working correctly and if your application has the correct setup. So that's the basics of the node application. So let me go back to my slides. So the event type that we're interested in looks like this example on the right. So when we receive a JSON event on 2G and we have this detail object inside it, we're looking for this PDP context. And this is the information that Jean-Ud mentioned that we're looking for to get the coordinates. So we're looking for the cell ID, which is this CI value, the location area code, which is this LAC value, and we look for the MCC MNC. And this we can also get in the PDP context object. Okay, then for the example that Jean-Ud already showed earlier on, this is what it looks like when it's deployed. So we have a data stream coming in, sending REST post requests to our application server. This K here stands for Heroku. So that's just a nice way to actually host our application, and we're using Node as a framework. So when these events come through and we're interested in doing some geo lookup, what we do is we make a post request to Google Maps API, and we get longitude and latitude back. Then we use Heroku's Postgres database just to store this information so that we have this whenever the app restarts, we can just read from the database, and we get this nice looking map afterwards. So I'm not going to go into too much detail on the actual JavaScript of the application, but we did make it available for you on GitHub already. So basically, to get this deployed is very simple, and that's why I really like Heroku. So when you have an account on Heroku and you have their tools installed on the command line, all you have to do basically is clone the repository that we've prepared for you already. You run this command Heroku create, and that creates a new project for you. And then you can run git push Heroku master, and that deploys the example that we're looking at. So we can take a quick look at the example application. So most of the interesting events actually happens in this views, pages, and the map page. So we're basically reading from our database after we have the Google Maps API, and we're placing these markers on Google's, basically a small Google Maps. So after we've created this application on Heroku, so they give you it's a project name, .herokuapp.com. And this is the end result of streaming endpoint information into our Heroku application. And there's some uses here of the Maps API where we can say we want to switch between different visualization forms. So basically, from a programmer's perspective, all we have is just an array with some coordinates, and we're saying whether to show them on the map or not. So using this heat maps visualization, we can switch between heat maps or the actual points. Maybe what we can look at is when we're actually writing this into a database. So that's in our main application file, which is this index. So new events will, when they're posted into the application from the data stream, we check that the event source is from the network, and this is where we get this location area code. We check the PDP context, and then we log this to a database. So the nice thing is we can also grab a couple of other bits of information about the endpoint, such as the endpoint name, the endpoint ID. We'll generate a timestamp, or we can grab one from the event itself. It's up to you how you actually build this. And the way we can use this is when we've logged all of this information to a DB, then we can enrich some of these markers. So if I click on this one over here, I can see this is a small HTML template that we create for each one of the markers. And we have the endpoint name, we have a timestamp, the latitude and the longitude. And because this is all templated here, the nice thing that we can do is we can click on this link and it should bring us to the endpoint itself, which is this one here. So it's endpoints/endpoint ID, and we can get all of the information that we want on the portal side from our application if we wanted to. So we have another device here, which is the EMnify. That's a Raspberry Pi that we have had in the office for a while. We can see there's a couple other markers that are placed on the maps. So there's a few different options that we can use for customizing how the map itself looks. These buttons here are just drawing lines in between the different points. I think at the moment this is between all points, but it would make sense if you just had lines in between the same devices to show where the device moves over time. So the Google Maps API is quite flexible with how you can actually customize all of this. So it's really up to your use case how you want to customize that. Then also another page that we're adding here, sorry for the flicker there. So another page that we've added is a table. And this shows the endpoint IDs. It's the same way that we template a URL. We have the endpoint name, the latitude, longitude, and also one value that we get back from the Google Maps API is the accuracy. So this will give you an idea of how close the marker is to the actual device, and then a timestamp in a human readable form. So this is that's about it in terms of this application. I think this was a quite quick one to throw together. It's based off Heroku's node example map. No, sorry, their node example application. So it's very, very quick to get started and to do some rapid prototyping there. We can take a look at the table page if you want to. It's actually very, very simple. So what we're doing is we have a header, which we can see here. It's this table header. And then we're constructing a table body based on the results from our endpoint. So we're just creating a new row and for each database entry, and we're adding in the endpoint name, the latitude, longitude, accuracy, and the timestamp. So the code itself is actually very, very simple, but the output is something that's very nice, and of course is very flexible depending on what kind of information that you want. If you wanted to create a publicly accessible URL for maybe you have a customer that you want to provide some location information, maybe they're interested in some other some other event information that the data stream provides. You could, of course, customize this and tailor it to your needs. So one of the reasons why I really like the REST API data streamer integrations is that it's basically, you can tailor this to whatever kind of need that you have. If you need to restrict some of the information that's being displayed here, that's completely up to you. It's very, very quick, I find, to rapidly prototype on demos like this. There's a lot of different applications, or whatever kind of application or framework you're comfortable with. You can build something very, very quickly that delivers value very quick. So I'm very interested to see what people build. And of course, if there's any questions about what I've shown so far, or if there's anything that I've skipped over, please let me know. You can let us know in the questions box here if there's anything that we've missed.